So for trucking, I did this data compilation for the last I don't know, like 8 years now. So I started in 2015. I had my fucking Detroit 60, a very nice engine truck. It was Freightliner. And yeah, I started with 99 Freightliner. Um, but I used different trucks over the years, and most recently I used. My last truck for this data was a 2007 Peterbilt, but it didn't really change. It didn't. The effect was the same. I don't know. It's kind of interesting that it. I got the same numbers. So the way this spreadsheet works is the way I set it up. Is this is the speed at peak, and I can do like let's say if I'm interested in usually. Let's say my weight. This is weight. Yep, load weight. So let's say load weight, we say empty, zero, right? So usually at load, so um, for example, here for this one, for this data point, I was driving at 56 miles an hour, or I decided to drive specifically at 56 miles per hour. And then I recorded precipitation during that time, temperature, direction of the wind blowing, wind speed, load weight, um, and then this was experimental ribs. Doesn't matter. I don't use it. Gallons, I do use it. So I recorded how much fuel I had. Then the stuff I don't record. Yeah, those were the main things. And so here, and then I record how and this trip I wouldn't take for very. So on average these ones were like 20 miles. So I'll drive on average for like 20 miles and record the miles per gallon. So I would have this data set, and I would have miles per gallon according to this information as well. And actually, I would break it up into how many gallons I used of diesel and how many miles I drove during the stretch. And so then next time, let's say I say I'm gonna drive empty, zero, load weight is zero, uh, gallons, 200 gallons, whatever, in tanks. For the weight, it calculates it. There's an equation for it. And I say, let's say, I check the weather. It's like 5% chance of precipitation, 17 degrees Celsius. It's wind is blowing, perpendicular to my drive direction, and then wind speed is, let's say, 4 miles per hour. Yeah, I fucking ended up using random fucking units, miles per hour, Celsius, whatever. And the load weight is zero. And then here, this line basically decides which data points I will include in figuring out what's the miles per gallon for particular speed. So, for example, I already know that at zero weight, usually optimal speed is somewhere around 58 miles per hour. So I start with that range. So let's say 57 miles per hour, and then it updates this to just adds one, as you can see, plus one. And so we have this. It calculates. This isn't a miles per gallon. This is actually gallons per 1,000 miles. So I did the inverse of it. So the lower number the better. So if I drive at 57 miles per hour, using these parameters, this weather, uh, I expect to use up about 97 gallons of diesel if I drive 1,000 miles. So 1,000 mile trip will take up like 97 gallons. If I drive 58 miles per hour, it will be 96 gallons. Oh yeah, I did the inverse here. Okay, I put it back as well. So here's miles per gallon. miles per gallon. So at 57 it's 10.3, 58 10.35, like insignificantly worse. And then at 59 we start, reducing, reducing our miles per gallon. So optimal speed would theoretically be 57, but here I added another column. So here is dollars lost compared to someone driving at 1 extra miles per hour. And basically, uh, this means that if I drive uh, 1 mile per hour more than this number, I will actually make 70 cents per hour extra, just because I'm driving faster, deliver loads faster. And this assumes $60 an hour. Like this assumes that I'm making $60 an hour while driving. So the faster I drive, uh, um, the more money I make. Um, 60. I forget how I calculated it, but basically you understand that if I drive faster, I make more money. And so this one calculates that this trade-off. I drive faster, I lose money on diesel, but I make money making delivering more loads or whatever, getting to places faster. And so if this number is positive, then I should drive at 1 mile per hour faster because I'll just make more money otherwise. And we can see it here. This one is really close. Like there's no reason not to drive 58 because it's almost the same as 57 miles per hour. Like miles per gallon between uh, these two numbers are almost the same. So fuel efficiency at these two numbers is almost the same, but you do more work at 58, so this number is positive. But this number is negative, which means if you drive at 59 miles per hour, yeah, like you'll do more work and you'll make more money because you deliver more loads, but you'll lose more because your fuel economy is starting to drop. And so that's so because this number is negative, that means you don't want to drive faster than 58. And then we can check different numbers. So at zero weight, this environmental conditions, it's 58 miles per hour is optimal. And I found it for all trucks to be true. Detroit, Volvo, Peterbilt, Caterpillar, all of the fucking trucks ended up with similar numbers. They all were like at zero weight, optimal at 58 miles per hour. And if you do like 40,000 pounds, boom, like I don't even have data because it was always shitty. So like I never even gathered data for these numbers. I mean, I gathered some data like during for different weather conditions, for example, but it just was never that good. So like I ended up gathering most data at most optimal speed. So I already know that's around like 62, somewhere there. And then we can see, okay, let's do 60. 60, yeah. So 60 is shitty fuel economy. 61, look at this fucking change. It goes from 7 miles per gallon to 8.5 miles per gallon. So that's this drastic change. So obviously you want to drive 61, but then you go past that, this number is negative because basically you're starting to lose quite a bit in diesel if you go to 62 miles per hour. And the extra work you do, assuming $60 an hour, is not going to cover the amount of diesel you lose. And also, obviously you're going to lose more than diesel. Where TR is going to be, the more diesel you use per mile, that means the truck is basically, engine is working harder, so the engine is going to blow sooner, higher risk of overheating the engine if the fan is not working. The tires are not efficient at that speed, so they're probably going to wear faster. But like every component is just working harder per mile, so it's not just diesel you're losing everywhere if it's if the truck has to work harder. So you run at 61 and it's optimal. So and 61 is basically optimal speed at 40,000 pounds. and then you like change direction, and that makes a difference. So let's say the wind is blowing at us. So not a lot of data for that. So when there's like not a lot of data, for because we're looking within 45 degrees. So this number means that we're looking at all the data that whenever I took the data, and the direction was between 0 and 45 degrees. So that's kind of, a tight, not a lot of data, also like temperature. So I started increasing the filter. So let's say we go with temperature like, I don't know, any. So nothing. So we still need to make bigger adjustments. Oh, load weight. So 700. That means that we're looking at load weight only between 40,700 and minus 700. So we gotta make a bigger window here. So let's say we're looking plus minus. So this is plus minus actually. So let's say plus minus 5,000 pounds, and booms. So now we have some data. So we have enough data in this range, plus minus 5,000 pounds, plus minus 45 degrees. Enough data gathered to have an estimate what we can expect. And then suddenly we can see that now it's 61. Well, it's 61. So yeah, 61 miles per hour is optimal. So let's say it's not blowing at us, it's blowing with us. So 180, it's like blowing in the back. So now if the wind is blowing in the back, fuel economy is best at 62 miles per hour, which that is like the same. Okay, it doesn't really change that much, interestingly enough. Oh no, 63. Look at this. Optimal speed is 63 miles per hour, because then we're like at fucking 8 miles per hour, and we make more money because we drive faster. So let's keep going. 64. Okay, and then it starts dropping at 64 miles per hour. So 63 miles per hour is optimal. So if wind is blowing with us, we want to drive at 63 miles per hour. That's best fuel efficiency. If the wind is against us, it's 61 miles per hour. So like all of this stuff, basically, you can change it, and then you can adjust the filter so that it gathers enough data from the historical data to have data here to show you, your estimate. Also, I can, if you want to hire me for anything like data analysis, I'm about to have two sons that I'm gonna be raising by myself. So I'm kind of looking for a job to uh, do remotely. So I was, throwing my hat in with that stuff. So if you go to Fever and you search like I will analyze your data, like you search for this text, I will analyze your data using best machine learning algorithms. Like this is me. You can like click on me and then hire me here for a project or whatever, or you can like hire me directly. Write in the comments. Write in the comments if you want me to analyze a different data, or if you have data that you want me to analyze, or you think. I mean, also suggestions like what do you think would be fun to analyze. But yeah, hit me up. Give me a job because I'm gonna really need the job that I can do remotely.